Okay, I will start this conference. Distinguished guests, ladies and gentlemen, now we have come to our next agenda, listening the presentation from the next keynote speaker from Professor Nilanchal Patel from Birla Institute of Technology, Mesra, India. All the presentation and discussion will be moderated by our moderator for today, Bapak Wahyu Tias Pramono, Magister Science. Allow me to read his short biography. Bapak Wahyu Tias Pramono, Magister Science, currently is a Geography Human Lecturer in the Faculty of Geography Universitas Muhammadiyah, Surakarta. He pursued his bachelor and master degree from Gajah Mada University. He writes, teaches, and researches in Geography Human and Geography Politics and Geostrategy. Hello, Bapak Wahyu, have you been ready?
Hi. Okay, I'm
Okay.
ready.
Okay. Bapak Wahyu Tias Pramono, Magister Science, the time is yours.
Thank you so much, Miss Auntie, for nice introductions. First of all, good afternoon to our participant and the invited speaker in the sixth International Conference on Geography and Disaster Management, or ICGDM, Universitas Muhammadiyah Surakarta, Indonesia. In these sessions will be our last four invited speakers in the first day of conference. Before we go further, I would like to introduce to our speaker today. He is Professor Nilanchal Patel from India. He is professor at the Birla Institute of Technology, Mesra, in state of Jharkhand, India. He obtained his PhD in remote sensing degree from IIT Kanpur, and his interests ranging from remote sensing, GIS, climate change, snow cover dynamic, urban pattern. To our participant, if you have any question, feel free to ask in the last sessions after our speaker presentations, both through chat box or direct by raising your hand first. Without further ado, we will listen from Professor Nilanchal about landslide hazard assessment in part of Himalaya mountains. Prof. Nilanchal, time is yours in 20 minutes. Namaste.
Namaste. Very good afternoon, everyone.
Good
And
afternoon.
to start with, I will express my sincere thanks to the chairman, organizing committee, and also my wishes to all the sincere participants here. It is a really honor for me to be considered to give a speech here on landslide hazard assessment in East Sikkim, India. So this presentation is a work done by one of my PhD scholars. And it is not the entire work, but the part of the work which he has done using the soil parameters to carry out landslide hazard assessment in East Sikkim, India. So the various factors that are found to cause landslide. Should I go to the PPT mode? Yeah. The various factors that cause landslides are listed here. Slope, rock formation, soil characteristics, land use and land cover, geomorphology, seismicity, tectonic activities, deforestation, road construction, road condition and utilization, drainage system, rainfall, and earthquake. The information or the layers, thematic layers that were used to carry out this study are listed here, and the source of the maps are also listed here. Slope map, land use land cover map, geological map, soil map, road map, drainage map, topo sheets, cartosat pan image, quick bar image, and landslide events map. So this is the broad methodology that has been used in preparing the landslide hazard zonation map. So we've started with the topo sheet, prepare a digital elevation model, then slope, then it was followed up by image to image registration, Then the topo sheet was again georeferenced with the help of reference map and GPS data, lithological map, soil map, administrative boundary map, transportation network map, drainage map, LULC, fault map. They were superimposed in a GIS environment. Then landslide information value for each land parcel was calculated, and based on the landslide information value using the criteria given here, the entire study area was categorized into 4 zones. Stable zone, where the landslide information value was found to be less than 14. Unstable zone, 15 to 23. Vulnerable zone, 24 to 27. And most vulnerable zone, greater than 27. It was again cross-checked with the actual landslides occurring in the study area. This one picture that shows the landslides occurring in the study area, recent landslides. This is the study area in India where the actual research was carried out. India, then this is the Sikkim. It is located here, a small state, but prone to many landslides every year, maybe more than 20, 30 of different scale and magnitude. And this is the area where the actual study was carried out, this area. This is more prone to landslide, East Sikkim. So this is the digital terrain model of East Sikkim. Then we use the soil inert texture map, in which we categorize the study area based on the soil texture, loamy, fine silty, coarse loamy, and fine loamy. This is the soil depth map based on the parameters that we got from the Soil Survey of India: deep, moderate shallow, shallow, very shallow. Then based on the drainage density in the study area, we classified the study area into 3 categories: excessively drained, well drained, and somewhat excessively drained. Then soil erosion also plays a very strong role in the landslide occurrence. So severe, moderate, and low soil erosional severity were determined using universal soil loss equation. Soil stoniness, how soil is really brittle or soft. Depending upon that, the study area was categorized into 3 types: high stoniness, moderate stoniness, and slight or low stoniness. Hydraulic conductivity is another parameter of soil that plays a very strong role in the sliding of the rock. So low, medium, and high soil hydraulic conductivity were mapped. Land use and land cover map and forest map. So we consider the area is in general highly forested and is comprised of scrublands. So dense forest, non-forest. Non-forest means these are the areas where either there is quarrying or habitation. Open forest and scrublands were mapped. This is a geological map of the study area: fault plains, foliation, main axial thrust, and the rocks: calcisilicate, marble, quartzite, and amphibolite, and other types of rocks were mapped from the Geological Survey of India map. And this is a revenue map according to the different the revenue circle, that is the administrative circles in the study area. The lines that are shown here, they basically represent one administrative zone, or you can say circle. And within each zone, how the different soil parameters are distributed. Again, the continuation of the earlier information. And this is how we assign weights to the different parameters. If the soil is deep, we consider to be most unstable and we assigned a weight of 4, moderate deep 3, moderate shallow 2, and shallow soil 1. Similarly, in terms of soil texture, most unstable, that is the sandy, coarse, and gravel loam, weight is 3, silty loam 2, fine loam 1. Severe soil erosion, weight is 3, moderate 2, and low severe zone 1. Texture, sandy, gravel, coarse, most unstable 3. Silty loam we consider to be moderately stable or unstable, assigned a weight of 2, and fine loam or clay considered to be stable because clay are quite sticky in nature and they are they resist the occurrence of landslide. So we assigned a stability weight of 1. Then in terms of stoniness, high stoniness we consider to be more stable 1, moderate stable 2, most unstable 3. Greater the weight, more instability. Less the weight, more stability. In terms of soil slope, more than 50 degree, most unstable, 30 to 50 degree, unstable, and 15 to 13 degree, stable. Soil drainage, excessively drained, 3, well drained, 1, and intermediate 1, 2. Hydraulic conductivity, these are the weights, high, moderate, and low, 3, 2, and 1, respectively. Then finally, we calculated the soil stability value using this formula for each polygon of the study area. The soil stability value is calculated using this formula. Soil stability value, SSV, is the summation of the stability weight of different parameters. And I discussed the stability weights assigned to the different parameters based on their intensity. So for each polygon or the land parcel, the stability weight was determined or calculated using this formula, summation of all the stability weights from different parameters. So now we classified the study area into 4 zones: most vulnerable, unstable, or stable, based on their soil stability values. So more than 15 to 16 we consider to be unstable, 17 to 19 vulnerable, and 20 to 22 as most vulnerable for landslides. And there are number of polygons and area in square kilometers. And finally, we prepared a zonation map based on the soil stability values. And this is what we have finally generated. So this kind of study has been done in the present study area. And in the multi-criteria stability zonation, we introduced some other parameters like entropy and other things that I have not included in the present slide. But this is what is the outcome from the soil parameters. And this is the outcome when the other parameters were also incorporated in the study. So this study is being continued. And this is what, in a brief, my presentation comprises. Thank you.
Thank you so much, Professor Nilanchal. Is there any questions from participants? You can use chat box or through direct questions by raising your hands and ask directly. So maybe from me, Professor Nilanchal, I have one question related to the um in the uh you know in the late of several oh sorry so from the participants, Mr. Aziz, he has questions about what recommendations would you make for improving landslide preparedness and mitigation in East Sikkim? Okay, this is question from Mr. Aziz. So I have another questions for you. So it's matter related to the climate change. Is that climate change also affect the occurrence of landslide in Sikkim area?
Mm, Probably not much, because the rainfall intensity is more or less constant in the Sikkim area. We are not finding much change there. No, not significant changes, except that some of the years it starts little early, some of the years it starts little late, but the duration of the rainfall and the amount of rainfall, it's spread or the distribution is more or less same for last many years. So primarily we consider the slope, soil deforestation, and habitation are the major factors in causing the landslides there.
Oh, me still mood. Any more questions from participants? We still have 3 minutes to go. If you have any questions, you can use chatbot app or through direct questions by raising your hand first. There's no more question. If no, I will give you certificate. Maybe I can share through this. Oh, I'm sorry, I cannot share because I'm not the presenter. Mr. Aziz, can you help me related to the handout of the certificate through Professor?
Please, Prof. Nilanchal Patel, could you turn off the share screen?
I'll stop it.
Yes, please. Okay. Okay, you can share the certificate, Mr. Wahyu.
Is still visible, what, Aziz?
Yeah.
Yeah. So this is certificate to Professor Nilanchal Patel as the keynote speaker for this ICGDM 2024 at Universitas Muhammadiyah Surakarta. Thank you for sharing your presentations and also the result of the research. This time, as the moderator, will give it to you. So I will press the screenshot at first. So once again, thank you so much, Professor Nilanchal. So time, I will hand up to Miss Anti Amania for the next session. Thank you so much.
Okay. Thank you, everyone. Thank you very much, Professor Nilanchal Patel. And also thank you very much, Bapak Wahyu Tias Pramono, Master Science. Ladies and gentlemen, we're going to the next session is still paper presentation. For the participant who are going to present the presentation, please join best on your room. All participants who are free to please choose the breakout room you wish to join. Following the paper presentation, I will send reminder to everyone that the presentation will be end until the presenter finish their presentation, and we'll continue this conference tomorrow. Thank you very much for the attention in ICGDM Day 1. Let's proceed with the paper presentation. See you all tomorrow at ICGDM Day 2. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.